There's an invisible system that's watching our world, right now. It sees our cities grow, it tracks a storm as it forms over the ocean. It even knows about the traffic jam on your commute. It's kind of like the eyes and the brain of our planet, this huge network of satellites and software, all working together. Today, we're going to pull back the curtain and see exactly how it all works.
Seriously, have you ever thought about that? Or how weather forecasters can predict a hurricane's path with such incredible accuracy? Well, it's not magic, not at all. It's this powerful combination of eyes way up in the sky and a massive digital brain right here on the ground. So let's dive in and peel back the layers.
Okay, so first things first. Before we can analyze anything, we have to collect the information, right? This is where our story starts, with the eyes that are constantly observing our planet from a distance.
The big idea here is called remote sensing. It's literally the science of seeing without touching. And believe it or not, this isn't some newfangled idea. It actually started way back in the 1800s, with these incredibly brave photographers strapping cameras to hot air balloons to get the very first aerial photos. I mean, can you imagine? Today, we've just swapped those balloons for some very powerful rockets.
So how do these sensors actually see? Well, they do it in two main ways. The first is called passive sensing. Think of it like using your own eyes on a sunny day. The sensor just soaks up the natural sunlight that's bouncing off of everything. But then you've got active sensing. This is more like using a flashlight in a pitch-black room. The sensor sends out its own pulse of energy, like a radar beam or a camera flash, and then it reads what bounces back.
All right, so we've made this giant leap from hot air balloons to incredibly sophisticated satellites. But here's the thing, not all satellites are the same. Where a satellite flies, its orbit totally changes its job. On one hand, you have geostationary satellites. These guys are way, way out there, orbiting at 36,000 kilometers. They spin at the exact same speed as the Earth, so it's like they're hovering over one single spot. This is how you get that constant, live weather map during a big storm. Then, much closer to us, you have sun-synchronous satellites. They fly lower and they scan the entire globe, strip by strip, giving us that incredibly detailed, long-term view of things like deforestation or our changing coastlines.
So this is the really cool part. How can a satellite tell the difference between a forest and a city? Well, everything on Earth, trees, water, concrete, you name it, it all reflects energy in its own unique way. It creates what's called a spectral signature. You can think of it like a color fingerprint that's invisible to our eyes, but for a satellite sensor, it's crystal clear. For instance, healthy plants reflect a ton of infrared light, so a satellite can color them bright red, while water absorbs that same light, making it look black. And just like that, you can map a flood from space.
So our eyes in the sky have gathered this just unimaginable amount of data. But raw data is just noise, right? To turn those billions and billions of pixels into something we can actually use, we need a brain. And that brings us to the next critical piece of this puzzle.
Let's just try a quick thought experiment. Go ahead and picture a basic map of your city in your mind, just the general outline.
Okay, got it? Now, imagine you're laying a clear sheet of plastic over that map. And on this sheet, the only thing drawn is the entire network of roads.
All right, you with me? Now let's add another clear layer on top of that one. This one only shows the outlines of every single building in the city.
And for the final layer, let's add all the green spaces, the parks, the rivers, the lakes. When you stack all of these simple layers together, you suddenly start to see these really complex relationships. What you've just built in your head, well, that's the core idea behind the planet's digital brain.
This whole system is called a Geographic Information System, or GIS for short. It's basically this incredibly powerful software that takes all kinds of geographic data, everything from those satellite images to property records, and it organizes it all into these smart, analyzable layers. This is what turns all those raw pixels into real-world answers.
So here's where it all comes together. When you combine the eyes, that's remote sensing, with the brain, GIS, you can do some truly remarkable things. This is where the data stops being just data and starts becoming a tool to make really important decisions.
See, GIS isn't just for making pretty maps, it's for asking those maps questions. Let's look at 3 really powerful ways it helps us find answers to complex problems every single day.
First up, there's something called buffer analysis. This is all about proximity, what's near what. So you can pick a point on the map, like a school, and tell the GIS, hey, create a 3-kilometer circle around this. The system can then instantly tell you every single house, park, or potential hazard inside that zone. It's absolutely crucial for things like urban planning or emergency response.
Next, we have overlay analysis. This is kind of what we did in our heads earlier. This is where we stack different map layers to see how a place has changed. So by overlaying a map of land use from the year 2000 with one from 2015, we can immediately see where forests have disappeared or where a city has sprawled outwards. It's a vital tool for understanding our impact on the planet.
And finally, network analysis. This one brings us right back to that question at the very beginning. This tool looks at a network, like a grid of city streets, to find the most efficient path from A to B, factoring in things like traffic, speed limits, even road closures. This is the engine behind your map app telling you to take that side street to dodge the traffic jam.
And the impact this has in the real world, it's just staggering. It's used for everything from finding hidden sources of groundwater in places suffering from drought, all the way to managing disaster response. For example, during the devastating 2018 floods in Kerala, India, this exact technology was used to create hazard maps, figure out the damage, and coordinate rescue efforts, all in real time. It literally saves lives.
And think about the GPS in your phone. That little blue dot that tells you where you are. It only exists because your phone is constantly listening for signals from at least 4 of the 24 satellites that make up the GPS network, all circling the Earth right now. It's this massive, invisible dance of remote sensing that most of us use every single day without a second thought.
You know, this quote really sums up the whole spirit behind this. These incredible systems, they weren't just built for technology's sake. They are the tools born from our own relentless curiosity. They really represent our deep need to understand our home planet, to try and manage it wisely, and to protect ourselves from its dangers.
And so, that leaves us with this incredible new reality. For the first time in human history, we've actually built a system that lets us see our entire world in near real time. We can watch the ice caps melt, the forests shrink, the cities grow. The question really isn't what we can see anymore, it's what will we choose to do with this incredible vision. And that's something for all of us to think about. Thanks for joining me.